In this video, I will be showing you how I modified my 3D printer to turn it into a plotter that can plot on physical objects like metal and wood. I started by designing a mounting mechanism. I took inspiration from how you would normally mount on a CNC, so I created a panel with holes in it so that you can move brackets around and screw them into the holes using 3D printed screws. I also modeled out a clamp that will allow me to attach the marker to the printer head. After printing everything, it looks like I may have needed to apply some brim to the bracket. It detached from the print bed and is no longer flat. So I printed it again with some brim to hold it in place. Then printed out screws and brackets. I then proceeded to print out some springs that will allow the user to apply pressure to the object that will be held down, and everything looks like it fits nicely. I also printed out a 2 cm squared cube that will be used to test out the plotter. The next thing to solve will be the z-offset. I will be using something physical to lift the print bed up while it is being leveled. This will cause the printer to think that the print bed is higher than it really is, so I modeled a platform that will hold the bed up during the leveling process. After printing it, I realized that it wasn't flat. However, it shouldn't be a problem, since when the nozzle will go down to find it, it shouldn't take that much pressure to push it back down. So I decided to use it anyway, and place it in between the print bed and the heated bed. And so I decided to send some G-code that will make the printer level out the bed. The G-code is using a custom material that I created. This material stops the printer from heating the bed by limiting its temperature. It also stops the extruder from pushing out plastic, shuts down the fan, and enabled Z-hop, so that while the printer is plotting, it doesn't drag the pen around to areas where it doesn't need to plot. The G-code contains a model of a square that is 1 cm squared. It also contains a small object. This is used to give the printer a delay, in order to increase the amount of time where the user can pause the printer in order to remove the frame and put in the pen and the object that it is plotting on. After starting the printer and sending the G-code, the plate started to fly around, so I stopped the printer before it damages itself. I decided to print out a few clips that will hold everything down. I assembled everything again. And this time, after sending the G-code, it worked. So after it went through the flow calibration, I paused it and removed the frame, attached the mounting bracket and the cube, and attached the marker. And then continued it. However, it didn't work. I forgot that the nozzle and the pen were offset from each other by about 2 cm. So I moved the square 2 cm backwards in the slicer, and after sending the G-code again, it worked, but I'm not really happy with the results. The color is closer to grey, so I got a darker permanent marker and tried it again. Okay, I guess we need to print out another holder first. I modified and printed a new holder, and went through the printing process again. And the square is more of a rectangle. This is caused by the marker moving at an angle, because the mounting bracket isn't perfect. So I checked it and realized that because I had increased the size of the holder, it is no longer flush with the print head. So I modified it, and after a few attempts, I got something that works. I made the area on the back flat, in order for it to stay in place. And I also increased the height of the bracket in order to decrease wiggle room. So I tried again and it worked. It looks like it's working much better now, but since the marker is very runny, it is seeping into the cracks, making it look disfigured. So I put on some tape and printed it again, and it came out much better. This problem should be able to be avoided by using a marker that is less runny, or by using a smaller one. But for right now, I'm going to try plotting on metal. I got this piece of metal from an old floppy disk drive, and I wanted to try drawing this gear onto it. I used the mounting equipment to secure it. However, it looks like when I try to insert the bracket at the end of the platform, it causes the mount to come loose. so I redesigned it to have more room, and now it works much better. After mounting it and applying a layer of tape, in order to go through the G-code and to put the marker at the right offset. The way I have been applying the offset till now has been to eyeball it and hope for the best. And since the frame that I use to apply the Z offset is 25mm high and the metal is 15mm of the print bed, I need to make the marker 1cm below the nozzle. However, if it is too high, it won't plot, and if it's too low, it will cause the marker to hit the metal while the marker is still moving towards the point it should start at, since it moves as a slope and not straight down. So by using a piece of tape to test, I will be able to check that it is at the right height. After running the G-code, it went through it without any major problems. But it looks like the marker was too low, causing it to hit the tape before it should have. So I moved the marker up a bit, and went through it again without the tape. And it's almost perfect. I probably could have used the tape again to make sure that it would be perfect. It's not in the middle and the marker still hit it slightly too early. However, if I were to be more patient, it would come out much better. I then wanted to try plotting on some wood. However, before doing so, I realized that the teeth on the gear are not the right shape. This is because the marker is thicker than the nozzle, which causes the plotter to thicken the object it is plotting. This can again be fixed using a smaller marker. However, I decided to instead try switching the printer nozzle and the G-code with 0.8mm nozzle instead of 0.4mm nozzle, which should improve it slightly, and it did. The gear is slightly better but not perfect. However, I decided to do a small experiment. Just like how you can apply a different amount of pressure to get different amount of marker to contact the paper when you are drawing, the printer should be able to do the same. So I moved the marker slightly up and plotted it again. And it worked perfectly. Since the size of the area of the marker contacting the wood had decreased and is now the same size that the nozzle is, the teeth on the gear ended up coming out in the right shape. I'm really happy with how it came out. I hope you enjoyed the video. If you have any suggestions, leave them in the comment section down below. Thanks for watching and see you next time.